Question number 1. All substances are made from atom. 1.1 is an AO2 question, and this question is from the topic of electric charges on subatomic particles, mass and size of an atom. If we look here in figure number 1, which is a structure of an atom, we can see here the atom consists of the nucleus and the shells which have the electrons. What is the number of protons and number of neutrons in beryllium atom? This is a beryllium atom. We can see the electrons are present in the shells and the protons and neutrons are present in the nucleus. We know that protons are carrying the positive charge and neutrons are neutral particles. If we count from the figure, there are 4 positive charges in the nucleus. The number of protons are 4, but if we count the number of neutrons in the nucleus, there are 1, 2, 3, 4 and 5. So number of protons are 4 and number of neutrons are 5. One point two is an AO2 question, and this question is from the topic of electronic structure and ionic bonding. The beryllium ion is given here. We can see that it has 2 electrons in its first shell and there are 4 protons present in the nucleus, 1, 2, 3 and 4. And protons are carrying positive charge, electrons are carrying negative charge, whereas neutrons, they don't have any charge, they are neutral particles. What is the relative charge on beryllium ion? We can see that the number of protons are 4, number of electrons are 2, and difference is coming here. 2 protons are extra in the nucleus, as each proton is carrying positive charge. Therefore, the charge on the beryllium ion is +2. Figure number 3 shows the arrangement of atoms in 3 states of matter, A, B, C. I elaborated it as solid, liquid and gas form. Student must know the properties of solid, liquid and gas. If I take it as an ice, B is acting as a liquid, I am taking it as water, and C is gas form, I am taking the water as steam. 1.3 is an AO1 question, and this question is from the states of matter. Which state of matter is represented by state C in figure number 3? We know that the particles of the matter are away from each other. The distance between them is much more as compared to B and A. Therefore, we will consider the state C as gas. One point 4 is an AO1 question, and this question is again from the topic of states of matter. What is the name of the process when state B changes into the state A? This is the liquid form, and the liquid changes into the solid form. When the state changes, the name of the process when a liquid changes into solid, that is called freezing. Therefore, the name of the process is freezing, because the liquid changes into solid form. 1.5 is an AO1 question, and this question is again from the state of matter. How can state B be changed into state C? If you look back into figure number 3, we have liquid here. A liquid changes into gas form. What should be done so the state B can change into state C? So as it changes from liquid to gas state, we need heating or boiling process to change the liquid state into gas state? Let's see the model answer. So figure number 3 helps us that the state B changes into state C by heating, by evaporation, or by boiling. Experimental evidences led to the scientific model of atom changing over time. 1.6 figure number 4 shows 3 models of atom. We can see here a solid sphere is present. Then the plum pudding model is present here, which is given by J.J. Thomson. Whereas the nuclear model is given here, which is given by Niels Bohr. John Dalton gave the idea that matter consists of tiny spheres or particles, whereas J.J. Thomson gave the idea of plum pudding model that the sphere is positive and electrons are stuck on different places on the sphere. Later on, Niels Bohr gave the idea that the central part of the atom is positive, whereas the electrons are present in the shells. What is the order of the development of the model of the atom? So we have to see that who gave the idea first about the model of an atom. So John Dalton gave the idea first, but later on J.J. Thomson gave the idea of plum pudding model, and later on the Niels Bohr gave the idea of nuclear model. So the correct answer is number C. As John Dalton gave the idea the atom consists of solid sphere, but later on at the end of the 19th century, J.J. Thomson gave the idea the atom consists of positive and negative charged particles, whereas the nuclear model in the beginning of the 20th century given by the Niels Bohr that atom consists of the positive charge in the middle and the negative electrons are moving around it. One point 7 is an AO1 question, and this question is from the development of atomic models. Complete the sentence. The student must remember the answer of this thing. Which person discovered the neutrons in the nucleus? If we look into the nuclear model, which was given by the Niels Bohr, there is no concept of the neutrons present in the nucleus. In 1932, Chadwick was a person who discovered the neutral particles in the nucleus of an atom. So, the existence of the neutrons was discovered by Chadwick. Question number 2. A student investigated the temperature change when magnesium was added to zinc sulfate solution. Figure number 5 shows the apparatus. 50 cm cube of zinc sulfate solution is present here. A ribbon of magnesium is added. This question is from the topic of the reactivity series and energy transfer during exothermic and endothermic reaction. (2.1) is an AO1 question, and this question is from the required practical activity number 10 of combined science. Which piece of equipment is labeled as X? If you go back to our figure number 5, the piece of equipment which is labeled as X is shown in figure number 5 is a thermometer. So the correct answer is thermometer. 2.2 is an AO1 question, and this question is again from the required practical activity number 10. Which piece of equipment is the best to measure the volume of the solution? Tick one box: conical flask, evaporating basin, or the measuring cylinder. If you look here, the conical flask, it doesn't have any graduated scale on it, but on the measuring cylinder we can see here it has a proper scale, so it can help to measure the volume of the solution correctly. So the best answer among these three is the measuring cylinder. The student added 1 gram of magnesium to 50 cm cube of zinc sulfate solution and measure the temperature increase. So it means it is an exothermic reaction. The student repeated the experiment 2 more times. Table number 1 shows the results. Experiment number 1, experiment number 2 and experiment number 3, and in the last column we need to find the mean of rise in temperature. Calculate the value of y in table number 1, and this question is an AO2 question, and this question is from the required practical activity number 10. We know that mean is sum of all the values, our total number of values. We have 3 values, 7.6, 7.3 and 7.6, and there are 3 values in our table number 1. So sum of all values divided by 3, and the answer is 7.5 degree. So the 2.4 is an AO2 question, and this question is again from the required practical activity number 10. The student then added 1.2 gram of magnesium to 50 cm cube of zinc sulfate solution. The temperature increased by 9 degrees Celsius. Calculate the temperature increase when the student added 0.4 gram of magnesium to 50 cm cube of zinc sulfate solution. So amount of the magnesium which is added in grams, that is 1.2 grams in 50 cm cube of zinc sulfate solution, and the rise in temperature is 9 degrees Celsius. The student need to find the rise in temperature when the mass of 0.40 gram of magnesium is added. So amount of the magnesium in gram is given here. When the amount is 1.2 gram, the rise in temperature is 9. When the amount of magnesium is 0.4, we need to find the change in temperature or rise in temperature. We mentioned it as x, and we will use ratio and proportion method to solve the question. We know that 1.2 is going to time with x and 0.4 is going to time with 9 by the ratio and proportion method. And when we need to solve the question, we need to make x as a subject. By using the calculator, our answer is 3 degree rise in temperature. When 0.4 gram of magnesium is added in 50 cm cube of zinc sulfate solution, the rise in temperature is 3 degrees Celsius. (2.5) is an AO1 question, and this question is again from the required practical activity number 10. What is the name given to the reaction which causes the temperature to increase? Tick one box. Endothermic reaction, exothermic reaction, or thermal decomposition. In endothermic reaction, the temperature of the surrounding it drops. In exothermic reaction, the temperature of the surrounding it increases. Whereas in thermal decomposition, the energy is required to break a compound in more than one substance. So the temperature is rising, it means the energy is going into the surrounding. Therefore, the correct answer is exothermic reaction. 2.6 is an AO3 question, and this question is from the required practical activity number 10. The student repeated the experiment with 1.2 gram of copper and 50 cm cube of zinc sulfate solution. The temperature did not increase. Give one reason. I use that activity series table which can help me to elaborate my answer, and the student need to give the reason why there is no change in temperature. If you look here in our reactivity series table, the copper is below zinc in our table. It means that copper is less reactive than zinc. Therefore, the copper is unable to remove the zinc from zinc sulfate because copper is less reactive than zinc. So the answer is copper is less reactive than zinc. Therefore, copper is unable to replace zinc from zinc sulfate. And students need to have a good understanding of reactivity series table. Question number 3. Structure and bonding is used to explain properties of the compounds. Metal atoms react with non-metal atoms to form ions. 3.1 is an year 1 question, and this question is from the topic of ionic bonding. Which group of elements does not form ions? Alkali metals are group 1 elements and they lose 1 electron from the outermost shell and get +1 charge. Halogens are from group number 7 and they gain 1 electron to complete the outermost shells and gain a charge of 1 minus. Whereas noble gases are from group number 8 or group number 0 and the outermost shells are completed. Therefore, they don't want to make chemical reaction. As a result, they are not making any kind of ion. So the correct answer is noble gases. 3.2 is an AO2 question, and this question is from the topic of ionic bonding. We can see here in the figure the potassium atom is present and chlorine atom is present here. Potassium belongs to group number 1 and chlorine belongs to group number 7. As potassium belongs to group number 1, therefore it has 1 electron in its outermost shell. Chlorine belongs to group number 7, therefore it has 7 electrons in its outermost shell. 1, 2, 3, 4, 5, 6 and 7. Potassium reacts with chlorine to produce potassium chloride, KCl. Figure number 6 shows what happens to the electrons in the outermost shell when a potassium atom reacts with a chlorine atom. The dot and cross represents the electrons in potassium and chlorine respectively. Describe what happens when a potassium atom reacts with chlorine atom to produce potassium chloride. Answer in terms of electron. If you look here, when potassium loses the electron from its outermost shell to chlorine, it gets +1 charge and become a positive ion. On the other hand, chlorine has shortage of 1 electron, it gains 1 electron, so it will become a chloride ion and get negative charge. The opposite charges, they will attract each other and make a compound that is called KCl or potassium chloride. Let's see the model answer. Potassium has 1 electron in its outermost shell and we know that it belongs to group number 1 elements and loses its electron to chlorine and becomes a positive ion with +1 charge. Whereas chlorine has 7 electrons in its outermost shell and it is belonging to group number 7 elements and gains 1 electron from potassium and become a negative ion. We can see here on gaining the electron it become a negative ion. 3.3 is an AO2 question. In a solid ionic compound, oppositely charged ions attract to form a joint structure. So we have ionic compound and we know that in the ionic compound we have the oppositely charged particles, positively charged and negatively charged particles. Which structure represents the arrangement of ion in solid potassium chloride? We know that it is an ionic compound. Potassium has positive charge and chloride has negative charge. We need to tick one box which shows the arrangement of ion in solid potassium chloride. If you look here in all three figures, the positive and negative they attract each other, but this positive and this positive they repel each other, this negative and this negative they repel each other. If you look into the second structure, this is positive and negative, but this negative is also present here, so they will repel each other. negative and negative, they repel each other, negative and negative, they repel each other. So this is a wrong structure. If you look into the last figure, the positive and negative, the negative to positive, this positive is attracted by the negative, this negative is attracted by the positive, and this positive is attracted by the negative. So we can see from this structure that positive is surrounded by negative and negative is surrounded by the positive particles. So the correct option is last one, which is C. Non-metal atoms share electron to form covalent bonds. 3.4 is an AO1 question. Water is a covalent molecule and is formed as a result of sharing of the electrons between hydrogen and oxygen. This question is from the topic of covalent bonding. Table number 2 shows the number of electrons in the outer shells of hydrogen atoms and of oxygen atoms. We know that oxygen has 6 electrons and hydrogen has 1 electron in its outermost shell. Figure number 7 shows part of dot and cross diagram of a molecule of water. Complete the dot and cross diagram. You should only show the electrons in the outermost shell. And the figure number 7 is given here. So we know that hydrogen has 1 electron, whereas oxygen has 8 electrons. 2 are in the first shell and 6 will left behind in the outermost shell. Whereas hydrogen has 1 electron only, so we need to use the dot and cross diagram to show the covalent bond between hydrogen and oxygen. If we consider here the hydrogen electron is represented by a dot, so it means we need to put 6 electrons in the outermost shell of oxygen. We have 1 here, then we have 2, 3, 4, 5 and 6. Now we count the number of electrons in the outermost shells after sharing of the electrons. Hydrogen has 1 and 2 shared pair of electron. So this hydrogen is satisfied. For this hydrogen, 1 and 2 shared pair of electron. So it has 2 electrons in the outermost shell as a result of sharing. We see the oxygen 1, 2, 3, 4, 5, 6, 7 and 8 electrons in the outermost shell after making the covalent bond. 3.5 is an AO3 question. Silica has a joint covalent structure, and this question is from the topic of covalent bonding. So silica means silicon dioxide, so it has SiO2. So for each silicon atom there are 2 oxygen atoms. Determine the ratio of silicon atoms to oxygen atoms in silica. Use figure number 8. So we know that silica means silicon dioxide. Between them the ratio is 1:2. So from figure we can see that it is 1:2. 3.6 is an AO1 question. Polymers have a large molecule. Figure number 9 represents a part of the structure of a polymer. We can see here a polymer number 1 and a polymer molecule number 2. We know that the polymers have the covalent bond present between the particles or the atoms, but the intermolecular forces are present between the polymer molecule 1 and polymer molecule number 2. These forces are weaker as compared to the covalent bonds. What holds polymer molecule 1 and polymer molecule 2 together in a polymer? We know that there is no strong force of attraction is present between the layers or the polymer molecules. Weak intermolecular forces are present between them, which is holding them together in the form of polymer structure. So the correct answer is weak intermolecular forces between the polymer molecules. 3.7 is an AO3 question. Figure 10 shows the melting point of a polymer as the length of the polymer molecule increases. The melting point is along y-axis, but the length of the polymer of the molecules is along x-axis. Describe the trend shown in the figure number 10. The student don't need to give the reason behind it. They just need to read the graph and try to describe the trend in the graph. If we see here, as the length is increasing, the melting point is increasing. The reason behind it is the force of attraction between the molecules or the polymer molecules is increasing. But this melting point is increasing up to a certain point. After that, even the length is increasing, the melting point is not increasing anymore. The student, they don't need to mention the reason in the answer. They just need to describe the trend, which is very simple. As the length is increasing, the melting point is increasing, but up to a certain point, the melting point is not increasing anymore and the graph is getting shallow. Let's see the model answer. In our model answer, as the length of the polymer molecule is increasing, the melting point of the polymer molecule is increasing, which we can see this part of the graph. Then the melting point levels off or stop increasing. Even the length of the polymer molecule is still increasing. Question number 4. Copper bromide solution is electrolyzed using inert electrode. Figure number 11 shows the apparatus. We can see here that this question is from the topic of electrolysis, and we have copper bromide solution. We can see here we have the electrodes. One is a negative electrode, another is a positive electrode connected to the battery or the power supply. 4.1 is an AO1 question, and this question is from the topic of metals as a conductor. Which particles carry the electric charge through the metal wire? If you look here in the figure number 11, we can see here the metal wire is present, and we know that the metal has a large number of free electrons which are responsible for conduction of electricity. Therefore, the particle which is present in the metal wire to conduct the electricity are electrons. There are 4 ions in copper bromide solution: copper ion, bromide ion, hydrogen ion and hydroxide ion. 4.2 is an AO1 question, and this question is from the topic of electrolysis of aqueous solution. 2 of these ions are formed when a water molecule breaks down. The symbol equation when a water molecule breaks down is given here. H2O, it breaks down into H plus and OH negative. Complete the word equation for the breakdown of a water molecule. So when a water molecule breaks down, it breaks down into hydrogen ion and hydroxide ion. So the correct answer is hydrogen ion and hydroxide ion. 4.3 is an AO2 question. Copper ions and bromide ions carry the electrical charge through the solution. So the copper ion is carrying 2 plus, whereas bromide ion is carrying 1 minus. What is the formula of copper bromide? Tick one box. And this question is from the topic of neutralization reaction and salt production. We can see here in our solution we have 2 ions, copper ion which is carrying 2 plus. So copper has lost 2 electrons to each bromine atom. As the result, it is making copper bromide CuBr2. So 1 copper ion, we need 2 bromide ions. So the correct answer is CuBr2. 4.4 is an AO1 question, but this question is from the required practical activity number 9. Explain why copper ion Cu2 plus move to the negative electrode. This question is from the topic of electrolysis of aqueous solution. Let's see the model answer. Copper ions are positively charged, therefore they are attracted towards the negatively charged electrodes during the process of electrolysis of copper bromide solution. 4.5 is an A1 question, and this question is from the topic of electrolysis of aqueous solution, and this question is from the required practical activity number 9, which is based on electrolysis of aqueous solution. Complete the sentence. Choose the answer from the box. We have three options given here: decomposed, discharged, and distilled. At the negative electrode, copper metal is produced when the copper ions are. So we need to pick one of the option, either it is decomposed, discharged, or distilled. If you look here in the equation, we know that copper ions, they will move towards the negative electrodes. As a result, they will take electrons from the negative electrode and it becomes copper atom. So we can see here the copper ion is discharged. It has a positive charge, but it loses a charge. As a result, it becomes a neutral particle. Therefore, the correct answer is discharged. At the negative electrode, copper metal is produced when the copper ions are discharged, means losing the charge. 4.6 is an AO2 question, and this question is again from the required practical activity number 9. What happens to the mass of the negative electrode during the electrolysis process? Tick one box. It is either decreasing, no change, or increasing. If you use the figure number 11 again, we can see here when the copper ions are coming, they will lose the electrons. As a result, they will become copper atom, which we already discussed in 4.5. Therefore, the copper atoms will stick to the inert electrode. As a result, the mass of the electrode will increase. Therefore, the negative electrode is gaining the mass because the copper atoms are sticking with the negative electrode. So the correct answer is the mass of the negative electrode during the electrolysis process will increase. There are four ions in copper bromide solution: copper ion, bromide ion, hydrogen ion, and hydroxide ion. 4.7 is an AO2 question, and this question is from the required practical activity number 9. What is produced at the positive electrode when copper bromide solution is electrolyzed? We have to see in figure number 11 that there are four ions present in the solution: copper ion, bromide ion, hydrogen ion, and OH negative ion, means hydroxide ion. The positive electrode is attracting the negative ions present in the solution, which are bromide ion and hydroxide ion. The rule is, if there is no halide ion is present in the solution, then the OH will go towards the positive electrode. We know that bromines belongs to group number 7 and it has negative charge. It will go towards the positive electrode. As far as it is present in the solution, OH negative will not be discharged. So the rule is, first of all, the bromide ion will be discharged, then the OH will get the opportunity to be discharged at positive electrode. So the correct answer is the bromine is formed at the positive electrode. If no halide ions are present in the solution, then OH negative will be discharged, otherwise halide ions will discharge first. And it has been mentioned here in the form of equation that Br negative will lose electron at the positive electrode and become Br atom. Question number 5 is again from the topic of electrolysis, and this question is from the extraction of metals by the process of electrolysis process. If you see here, the aluminium is extracted from a molten mixture of aluminium oxide and cryolite, which helps to reduce the melting point of aluminium oxide. If you look here in figure number 12, we can see here The positive electrodes are made up of carbon, whereas the negative electrodes are also made up of carbon. The molten aluminium is present here. 5.1 is an AO1 question, and this question is from the topic of electrolysis process. Complete the sentence. The extraction of aluminium is expensive because the process uses a large amount of energy. Student can also write the word electricity. We can see here during the process when the molten aluminum is extracted, a large amount of electric energy is required to produce aluminum from aluminum oxide. 5.2 is an AO1 question. Oxygen is produced at the positive electrode, which is a carbon electrode. I highlighted the important points of the question. The oxygen reacts with carbon electrode. Which gas is produced when oxygen reacts with the positive carbon electrode? If we go back here in our figure number 12, we can see here in figure number 12 that when oxygen is formed at very high temperature, it reacts with the carbon and a carbon dioxide gas is formed. As carbon dioxide gas is formed, it moves into the air. Therefore, as a result of electrolysis process, the oxygen is produced, it reacts with carbon and make the carbon dioxide, CO2. Titanium is extracted from titanium chloride by reacting titanium chloride with sodium. The reaction between titanium chloride and sodium is carried out in an inert atmosphere. Inert atmosphere means to avoid contamination in the process. 5.3 is an AO3 question. Suggest why the reaction is carried out in an inert atmosphere, and this question is from the topic of group 1 elements and reactivity series. The objective of the inert atmosphere is so that sodium can react with titanium chloride and remove titanium and make a chemical reaction with chlorine and make sodium chloride. As a result, we can extract titanium from titanium chloride. If the reaction is carried out other than the inert atmosphere, the chances are the sodium will react with the other substance instead of reacting with titanium chloride. Let's see the model answer. Sodium is very reactive and will react with oxygen, and titanium would not be extracted. As the result of that, the process or the reaction will contaminate it. 5.4 is an AO3 question. Complete the sentence. Use the answer from the box, and this question is from the topic of group 0 elements. The gas used for the inert atmosphere is inert, mean we need an inert gas which is not involved in any chemical reaction, that is argon. Chlorine and hydrogen try to make a chemical reaction, whereas argon belongs to group number 0 or group number 8 elements, so it does not want to make a chemical reaction. So therefore the correct option is argon gas. 5.5 is an AO2 question, and this question is from balancing the equation. The concept of atoms, elements and the compound. We can see here a chemical reaction is given here. Titanium chloride reacts with sodium and we get titanium and sodium chloride. We need to balance our equation. We can see here there are 4 chlorine present here, 4 sodium atoms are present here, but we need to put the number in front of sodium chloride. To balance the equation on the right side, if we are going to put 4 in front of the compound, then we need to count the number of sodium and the number of chlorine atoms on the left or right of the equation. We can see here there are the 4 chlorine on the left, there are 4 chlorine on the right, there are 4 sodium on the left, there are 4 sodium on the right. There is 1 titanium on the left, there is 1 titanium on the right. At the end we can say that the equation is balanced. Copper is extracted from copper oxide by reacting copper oxide with carbon. The apparatus is given here. A crucible is present. The mixture of copper oxide and carbon is present here. it is heated. As the result of that, carbon dioxide gas is formed and it is going into the atmosphere. The chemical reaction is given here. We can see in the chemical reaction, copper oxide reacts with carbon. As the result, we can see the copper atom is formed, means the copper is reduced and carbon dioxide gas is formed there. In an experiment, 15.9 gram of copper oxide and 1.2 gram of carbon are reacted. 12.7 gram of copper 12.7 gram of copper is produced in the chemical reaction. Calculate the mass of carbon dioxide produced in the experiment. So the total mass on the left hand side of the equation is 17.1 gram, whereas the mass of copper produced, that is 12.7 gram. The difference between these two values is 4.4 gram of carbon dioxide is produced and it moves into the atmosphere. So the correct answer is 4.4 grams. And this question is from the topic of conservation of mass and change in mass when the gas is produced. 5.7 is an AO2 question. Explain why the mass of content in the crucible changed during the experiment. We can see here the change in the mass is 4.4 gram. The initial mass, which on the left side of the reactors, is 17.1 gram. After the reaction, we can see here the amount of the copper obtained is 12.7 grams, whereas 4.4 gram of carbon dioxide is produced. It goes into the air, which is about 4.4 gram. As the result, the mass of the remaining content is reduced after the reaction. Let's see the model answer. Carbon dioxide gas is formed during the reaction and escapes into the atmosphere. Therefore, there is decrease in the mass of the contents. 5.8 is an AO2 question, and this question is extraction of metals and reduction method. What happens to copper oxide in the reaction? Give one reason to your answer. Use equation for the reaction. So we have three options. We need to pick one option. We need to find what happened to copper oxide in the reaction. We know that copper has oxygen, and when it reacts with carbon, it makes carbon dioxide and copper. So this copper on the right hand side does not have oxygen. So we will say that it is reduced from copper oxide to copper. Therefore, the oxygen has been removed from copper oxide compound. As the result, we got copper and carbon dioxide. We can see the copper has lost oxygen, and the loss of the oxygen is called reduction. So we will say that copper oxide is reduced. And the reason behind it is the copper oxide has lost the oxygen and reduced to copper. So the correct option is copper oxide is reduced. And the reason is loss of the oxygen is called reduction. Question number 6. This question is about carbon dioxide. Carbon dioxide is soluble in water and form an acidic solution. 6.1 is an AO1 question, and this question is from the topic of pH scale and neutralization. Which ion makes the solution acidic? So the student must know the ion which is going to make acidic is hydrogen ion or H+. Let's see the model answer. Hydrogen ion in a solution makes a solution acidic. So the hydrogen ion in the solution makes a solution acidic, whereas for alkaline solution we have OH negative. 6.2 is an AO1 question, and this question is again from pH scale and neutralization. Name an indicator that could be used to test if the solution is acidic. Give the result of the test. So the indicator we will use, that is universal indicator. And when we use the universal indicator, we can see the color of the indicator changes from green to red. Or the student can write it green to orange or yellow color. If the student want to use indicator as litmus paper, then the color will change from blue to red in the case of litmus paper. If the student want to use methyl orange, the color of the methyl orange changes from orange to red in an acidic solution. Students should not use the pH meter because the examiner is looking towards the different kind of indicators which a student can use in an experiment. Figure number 14 shows the mass of carbon dioxide that will dissolve in 1 dm cube of water at different temperatures. The mass of carbon dioxide in grams dissolved in 1 dm cube of water is along y-axis, whereas the temperature of water is along x-axis. We can see here as the temperature is increasing, the graph is going down. It means that solubility of carbon dioxide is decreasing. Six point three is an AO3 question. How does the solubility of carbon dioxide change as the temperature of the water increases? This question is from the topic of concentration of solution. From the graph, we can see that as the temperature of the water is increasing, the solubility is decreasing, meaning the mass of carbon dioxide in the water is decreasing. So we will say that the solubility is decreasing. 6.4 is an AO3 question. Carbon dioxide dissolves in water to form an acidic solution. This question is from the concentration of solution, pH scale, and neutralization. How does the pH of the solution change as the temperature of the water increases? We know that as the temperature is increasing, the solubility is decreasing. It means that the solution is less acidic. If the solution is acidic, we are on the left side of the scale, and if the solution is neutral, we have pH that is about 7, and if the solution is alkaline nature, the pH is towards 14. We know that as the temperature is increasing, the solution is less acidic. It means that pH is increasing. So the answer is, as the temperature is increasing, the pH of the solution is increasing. And the reason is the solution is less acidic. Calcium carbonate reacts with hydrochloric acid to produce carbon dioxide. The equation is given here. Calcium carbonate reacts with hydrochloric acid. It makes calcium chloride, carbon dioxide, and water. 6.5 is an AO2 question, and this question is from the topic of state symbols. What is the state symbol X in the equation? We know that as the reaction between an acid and alkali or the base gives salt and water, so therefore we have H2O in liquid form. So the correct symbol is L. 6.6 is an AO3 question, and the figure number 15, we have different equipment which are given here. We have conical floss, we have the gas range with the stopper, we have the miring scale, and we have miring cylinder also. Let's see the question. The student investigated the volume of carbon dioxide produced when different masses of calcium carbonate react with hydrochloric acid. Describe a method the student could use. It is an AO3 question. The student need to describe the method, and this question is from neutralization reaction, and the mass changes when the gas is formed. In figure number 15, we can see here we have the gas range. First, with the help of the digital scale, we are going to measure the mass of calcium carbonate, and we add that mass in conical flask. With the help of this miring cylinder, we will find the fixed volume of hydrochloric acid, and we add the hydrochloric acid into the conical flask which has already calcium carbonate. As far as we added hydrochloric acid in the conical flask, we will put the gas range along with the stopper immediately so the carbon dioxide is not escaping from the conical flask. Leave the gas range for a couple of fixed minutes like 10 minutes, 5 minutes or 20 minutes and measure the volume of carbon dioxide produced for each mass of calcium carbonate. The student need to remember that the volume of hydrochloric acid is fixed for each experiment. Let's see the model answer. Use the digital balance to measure the mass of the calcium carbonate and add in the conical flask. Then use the mining cylinder to measure the fixed volume of hydrochloric acid each time and add in the conical flask. Immediately place the stopper having the delivery tube connected with the gas range to the conical flask. Record the total volume of gas means carbon dioxide produced in the gas range in the fixed time interval for each mass of calcium carbonate. Repeat the experiment for different masses of calcium carbonate with the fixed volume and the same concentration of hydrochloric acid. In this experiment, the time for each experiment will remain fixed, whereas the volume and the concentration of hydrochloric acid is also remain fixed during each experiment. The student need to change only different masses of calcium carbonate to observe the amount of carbon dioxide produced by different masses of calcium carbonate. Question number 7. Lithium hydroxide reacts with sulfuric acid to produce lithium sulfate. The equation is given here. Lithium hydroxide reacts with sulfuric acid, forms lithium sulfate, which is a salt, and water. Along with that, we can get heat which is going into the surrounding. 7.1 is an A1 question, and this question is from the required practical activity number 8. What type of the reaction is this? We know that whenever an alkali reacts with an acid, it is a neutralization reaction. But on the other hand, as the result of neutralization reaction, the heat is produced, so it is a neutralization reaction. And if the students wants to write exothermic reaction, still the answer is correct. Let's see the model answer. So it is a neutralization reaction and the student can write as exothermic reaction. 7.2 is an AO2 question. Calculate the relative formula mass of sulfuric acid. Whereas relative atomic mass of hydrogen is given, oxygen is given, and sulfur is also given. We need to form the relative formula mass of the sulfuric acid. Let's see the model answer. And this question is from the relative formula mass. MR of sulfuric acid, that is, we have two hydrogen, 2 times the mass of one hydrogen, plus sulfur is only one. We have one atom of sulfur, so it is 32 only, whereas we have 4 oxygen, 4 times the relative atomic mass of one oxygen. So we have 2 plus 32, 4 times 16 as 64. When we add them with the help of the calculator, we can find the relative formula mass of sulfuric acid is 98. 7.3 is an AO2 question, and this question is from the concept of relative formula mass. Calculate the percentage by mass of oxygen in lithium sulfate Li2SO4. Whereas relative formula mass of lithium sulfate is already given, we don't need to calculate, that is 110. We need to find the percentage mass of oxygen in lithium sulfate. We know that there are 4 oxygen in lithium sulfate. We have to give our answer up to 2 significant figures also. Let's see the model answer. There are 4 oxygen which we can see in our formula, and the mass of each oxygen is 16. So we can find the relative formula mass or relative atomic mass of 4 oxygen, that is 4 times 16, that is 64. To find the percentage of oxygen in lithium sulfate, we need to find how much oxygen is there by mass, that is 64. What is the total mass or total MR of lithium sulfate, that is 110 times by 100. So we can see here in lithium sulfate, oxygen is contributing 58.18% by mass. But the question is, we need to find our answer up to two significant figure. So we have to go first to a significant figure, that is 5 and 8. By rounding it, we will get the answer as 58% by mass of oxygen. 7.4 is an AO2 question, and this question is from the concentration of solution. A solution of lithium sulfate contains 0.3 gram of lithium sulfate in 25 cm cube of solution. Calculate the concentration of lithium sulfate in gram per dm cube. So it is centimeter cube. We need to convert centimeter cube into decimeter cube. The given is 25 centimeter cube of solution. We divide it by 1000 to convert centimeter cube into decimeter cube, because 1 decimeter cube is equal to 1000 centimeter cube. So volume is 25 divided by 1000 and it becomes 0.025 dm cube. The given mass of lithium sulfate is 0.30 gram. We need to find the concentration of lithium sulfate. We have the formula that concentration is mass per volume. The mass is already given 0.3 and we already changed 25 centimeter cube into 0.025 decimeter cube. We will substitute these values in the required places, and by using the calculator, the concentration answer is 4 gram per dm cube.